Welcome to Physical Science. Today we're going to be talking about density again. I know we talked about density last week. I performed some demos for you guys to see what density is all about. Today we're going to learn how to calculate density given some variables such as mass and volume. So let's take a look. Our goal for today is to learn how to calculate density given the mass and the volume. It's our learning goal for today. And it'll basically take us probably, since the start of this video, maybe a total of 10 or 5 minutes to talk about density a little bit in terms of what it is. And then we'll look at the equation for a few minutes, and then we'll work on some problems together. So let's go ahead and get started. So calculating density requires us to know what the definition is. So by way of review, we should already know that density is a measure of the amount of mass that we find in a certain volume. So we have an object with a specific amount of mass and a volume that we already know. From that we can calculate density. So this is a physical property, density is. It's not a chemical property. And this physical property is often used to identify and classify substances. So that brings us to the density equation. So to calculate density, we simply divide mass by the volume of the object, and that will tell us what the density is. We can use the symbols D for density, M for mass. So matches up like this, and of course V for volume. Pretty straightforward, easy to remember. They all start, each symbol is the first letter of that word. Alright, that doesn't always work, but in this case it does, so that's good. So here's the first problem. We're going to put this into action. So I've set this up in a table where we can kind of step through each step of the process. This is kind of the cognitive piece here. We're thinking through how we're going to work out the problem. So we're given a sample, and this is on your worksheet. So if you don't have your worksheets open, you might want to pause the video, open the worksheet for today's lesson, and then you'll be ready to go. So the problem statement is we're looking for the density of a ball, and this ball has a volume of 10 centimeters cubed and a mass of 32 grams. So the first thing we want to do is write down our formula, which by now we have memorized. D equals mass over volume. Okay? So that brings us to our variables. Now variables are simply parts of the equation, information that we have. So one variable is the volume, and another variable is mass, and density is actually another variable. So there's three variables involved here, and they're represented in our formula. So our mass, we're told, is 32 grams, mass of 32, so we just bring that over and plug that in. And our volume is 10, so we plug that in. Okay, so now we have our variables defined. Now we can use a substitution process to put our numbers in to where the letters are, and then we can do the math. So that gives us density equals mass divided by volume. Okay, and when we do the math, oops, I did that wrong. So density equals mass over volume. What I wanted to do was substitute. I forgot to substitute. So for M, it's 32. And for volume, it's 10. So that's an easy calculation to do. 32 divided by 10 is 3.2. Now I do want you to note that our unit is grams per centimeter squared. When you see the slash, you can just say per. So 3.2 grams per centimeter squared. Or cubed, I'm sorry, that's a cube, that's a 3. Okay, so also notice that I left out my units over here. So we want to look at this again. So 32 grams and centimeters cubed. So that's basically the same thing right here that we have over here. It's grams divided by centimeters cubed. But when we put it together as one unit, we just say grams per centimeter cubed, which essentially means the same thing as dividing. Okay? So let's take a look at the first problem from your worksheet after the example. And it says that a piece of tin has a mass of 18.4 grams and 3.26 centimeters. What is the density? So we need our formula. We're solving for density. So density equals mass and volume. Fortunately, we have a volume and we're given a mass. So we're going to be able to use those as our variables. So that gives us M for mass equals 18.4 grams and volume equals 3.26 centimeters cubed. Now we can do our substitution. And that gives us 18.4 grams divided by 3.26. And I need to put my units in there, centimeters cubed, which gives us an answer. When we calculate that, you simply divide 18.4 divided by 3.26, and that gives us 5.64 grams per centimeters cubed. Okay, let's try the next one. A man has a 40 milliliter bottle. It's completely filled with 123 grams of slimy green liquid. So what is the density? We're solving for density, right? Of course. So density equals mass divided by volume. So when you do some of the independent practice, I expect you to fill out all of these columns on your table as well, same way that I'm doing here. That way, that'll really help you memorize that density formula without even really trying too hard. So now we need to define our variables. Our variables, again, are just the pieces of information that we have. So we have grams and we have milliliters. But it doesn't say volume or mass this time, so we're going to have to figure that out ourselves. So mass is always more like a weight, so it's weight in grams, and volume can be some kind of a three-dimensional figure. So 40 milliliters is actually the same as saying 40 centimeters cubed, because if you recall the metric ladder, milliliters and liters are 3 steps away. So it would be 0.400 liters or 0.40 centimeters. So it all works out to be actually the same. Now centimeters cubed just means it's in 3 dimensions. Alright, and any kind of a liquid we have would be in 3 dimensions too. So it actually works out to being the same. So our mass is the 123 grams and our volume is the milliliters. So you can leave it as milliliters, or you could write centimeters cubed in there if you wanted to. Either way is fine. So we do the substitution, and we'll just leave it with milliliters for now. So density equals 123 grams divided by 40 mLs, and that gives us an answer when we divide that of 3.08 grams per milliliter. So again, we could either do grams per milliliter, or we could just convert it to grams per centimeters cubed. Either way is the same. It's the same answer. Okay, let's try number 3. What is the density of a piece of wood that has a mass of 31 grams? There, this time we're given the mass again, and a volume of 27.2 centimeters cubed. So what is our formula for solving for density? What is the density? That's the question that's being asked. So we're looking for density. So what does density equal? D equals, and we know the formula to solve for D is M over V. Now we can do our substitution, which gives us m equals 31.0 grams, and volume is 27.2 centimeters cubed. And that leads us to our substitution step. Density equals 31 grams divided by 27.2 centimeters cubed. And when we do the division, it gives us 1.14 grams per centimeters cubed. So that would be the answer that we get. Let's try number 4. So let's figure out, what are we solving for? What is the problem asking for? Oh, it says down here, what is the density? So it's asking for density. So it's D equals. If it was asking for mass, it would be M equals. But it's asking for density. So density's formula is density equals mass over volume. Now we have to find our mass and our volume. It's not told to us directly in here, but we can tell that because 43.7 is in grams, that's our mass, and 32 milliliters, which is what's filling the container, is our volume. So our variables are M equals 43.7 grams and V equals 32 milliliters. Now we're going to substitute our numbers for our letters so we can actually do some math. 43.7 grams divided by 32 milliliters. And again, we don't have to change that to centimeters cubed. We can if we want, but it's the same thing. So it would be 32 centimeters cubed if you want to change it. And we just divide those. 43 divided by 32, and we get 1.37 grams per milliliter. So for every 1 milliliter, there's 1.37 grams, and that gives us a sense of the density. Okay, so that's what it's telling us. The density is this much, and here's density's unit. Okay, last one, and then I'll let you try some on your own. So number 5 says a block of aluminum occupies a volume of 21.0 milliliters and has a mass of 80.2 grams. What is its density? So what's the problem asking us to solve for? It's asking us to solve again for density. So density equals mass over volume, which you should practically have memorized by now. Now we have to define our variables. We've got a volume of 21. And we have a mass of 80, so that brings us to our mass and our volume. So now we're going to substitute .0 grams divided by 80.2. Looks like a backward 6. 2 milliliters, and when we divide that out, it gives us 0.26 grams per milliliter squared. Alright, so now it's your turn. So you're going to complete 8 of the 12 problems that are on page 2. You can complete any 8 you want. They don't have to be 1 through 8. You can bounce around if you really want to. If you do all 12 of the problems, I'll give you up to 4 points of extra credit, 1 extra credit point for each problem you do beyond the 8. And if you need any help, send me a Schoology message and I'll be happy to help. So, did we meet today's learning goal? You should now be able to calculate the density when you're given the mass and the volume. So hopefully that is the case, and I'll be able to tell if that is the case by your answers to the problems on page 2.